Good afternoon, everyone, and welcome to this webinar on space and the sustainability challenge. Just by way of introduction, my name is Paul Pitcher. I'm an aerospace engineer. I've got experience across civil aerospace, military aerospace sector, even spent a little bit of time in the naval nuclear sector, but now I find myself in the space sector. I'm also part of the IMechE. I'm a volunteer there. I'm a volunteer in the group that focuses on energy, environment, and sustainability. And I've been in that group for quite a while now. So, in a way, I've got something of a unique perspective in that I'm an aerospace enthusiast, but also, I'm a passionate hill walker. I've got a keen interest in sustainability. So I'm hoping that kind of comes across in the webinar. So then, actually introducing the webinar itself. Objectives for today, really. The webinar, I want it to be informative. So I would say that's the primary objective, really, is to just be an informative, useful presentation, and to think about the sustainability challenge and its application to the new space industry, the emerging space industry as we know it today, and to give something of a status update as well on the industry, and talk a little bit about some of the new challenges that are emerging. So that's an introduction to the webinar. But then also let's introduce the industry itself, and let's have a look a little bit at the history of the space industry. So, thinking about just what's brought us up to this stage that we're at today, in that 1957 was the launch of Sputnik. Was one of the first objects in space, although actually the first object to be orbital was the fairing from the rocket that Sputnik was launched from. So actually Sputnik was not the first satellite. The fairing was, but I guess that kind of perspective is more important nowadays as we think about debris and these things, but just an interesting fact anyway. But then in 1961, Yuri Gagarin, of course, being the first human to orbit the Earth, an incredible feat if you think about what he actually achieved in that mission. And in 1969, the moon landing. So a focus on human spaceflight in that time. Then as capabilities expand, we have things like GPS going up in 1978. Space shuttle as well in the 80s and 90s. And then that brings us very much up to kind of modern day. With 2002, SpaceX was founded, and they're obviously very much in the headlines nowadays. An important date as well, 2014, is that up until that point, any satellite technology was military classified in the United States. So up until that point, if you were dealing with any kind of technology to do with space, then really it was very tightly controlled, to the same level that the military information is controlled. However, under the Obama administration in 2014, that was withdrawn, and that actually had a certain energizing effect on the industry as this kind of constraint was released. So that kind of brings us up to present day in a sense, and these kind of times of the noughties and the 2010s brought the emergence of what we now call the new space industry. So let's talk about that for a few minutes. Really, essentially, the new space industry is a commercial space industry, and really that's as opposed to most of the efforts in what you might call older space, or the space industry of the past. It was much more the area of governments and nations that were doing these efforts in the space race, and putting these kind of headline projects which really bolstered national pride, and that had an amazing kind of molding and formative effect on what it meant to be something that we would call space grade. You know, as you if you're a nation, then you cannot really afford failure, especially when, you know, tragically some of the effects might be loss of life. So therefore, you know, in particular with if you think about the shuttle program and some of the tragedies in the shuttle program, this drove more and more high reliability requirements into the components that are used and the processes that are used. They gave birth to what we kind of now call space grade. Um, but if you're a commercial organization, then you know, it's your decisions on risk are much more motivated by cost. Um, and one of the main forces in the new space industry is the reduction of cost, fueled as well by, as I say there, the second bullet point, miniaturization. So, you know, actually being able to fit a computer onto a very small satellite. In history, computers were enormous, of course, but with that continual force of miniaturization, we now can fit quite sophisticated systems into very small satellites. And using, as I say, cheaper components, non-space grade components, commercial off the shelf components, you know, automotive grade components. This gives a lower cost access to space, essentially. Whereas, as you can see there, a CubeSat might be 100K to get into orbit versus the satellite in the past might have been something like 10 million, you know. And you can see that in the figure that I've given here, where in orange there you've got the commercial very much coming to the fore in the 2010s, and it's kind of nascent form in the noughties as well. Whereas in the past it was much more military or civil projects. So that's number of objects on the y-axis there and year on the x. So that kind of gives a bit of an introduction to the new space industry at large, if you like, but then just kind of bringing things closer to home. We're broadcasting from the UK today, so let's have a look at the UK Space Agency, or the UK space industry. And helpfully, the government produces this report. It's called the Size and Health of the UK Space Industry Report, and that gives an overall picture of what's happening in the industry. So already quite a significant industry. When the report was issued in 2017, the sector was at 13.7 billion pounds already, and that's grown across the 3 years to 2020 up to 16.4 billion. Employment as well, increasing significantly, with targets to grow even further, 40 million by 2030. Interestingly as well, manufacturing of spacecraft is something that I guess people might associate more with other countries, but actually manufacturing is very strong in the UK, with some really key, actually quite world-leading companies in the UK. So manufacturing is rising as well. And I've got that graphic there, which is straight out of the Size and Health of the Industry report there, which gives you a little bit more of a picture of how the industry can be thought of. So you've got the users of satellites and what satellite technology are doing, such as commercial users like companies, consumers, and public users. But then in the red inner circle there, you've got actually, well, what is the space industry? And a big part of the space industry is what you call space applications, which is the application of and use of the assets which are already in space. So this is maybe the purchase of data or the purchase of images or some kind of monitoring or Earth observation or telecommunications services or data. So that's a big part of the industry. And then inside there you can see space manufacturing, so that would be construction of satellites, and then also space operations, which is a massive part. It's one thing to manufacture a satellite; it's something completely different to actually operate it on a day-to-day basis and talk to it and monitor its health. which we'll come onto a little bit more detail on that as we get into the webinar. So that gives an introduction, if you like, to the industry at large, brings things a little bit closer to home. So that's a space industry, if you like. But what about this sustainability part of things? So let's spend a few moments just looking at sustainability. And as you know, it's important to define your terms, isn't it? So let's have a look at some definitions of sustainability. Some of the best known ones are I've listed here. So there's one from the Brundtland Report, which is one of the most important reports of the last century on this topic. And it says sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is very much thinking about the world for my children and my children's children. Will they still be able to enjoy natural resources and all of the services and satellite technology that we enjoy today? There's another definition there as well from the Engineer of the 21st Century Inquiry, and that says sustainability can be defined as the capacity for continuance into the long-term future. So there are a great many activities that could be considered sustainable in the short-term future. You know, that you can do a lot of things for a few years without really feeling many ill effects. But the important part there is continues into the long-term future when we're thinking, 20, 30, 40, 50 years into the future, is what we are doing still going to be possible, still going to be so unconstrained, and what constraints might emerge that we can preempt now and actually have already built resilience into our companies and into our engineering and into everything that we do. So that's a little bit of an introduction to sustainability, and I guess another way to look at it as well is, what does sustainability not mean? So just on the next slide then, what does sustainable not mean? Well, the buzz term, of course, nowadays is net zero, and I certainly don't want to make any point about aiming to be carbon dioxide net zero being a bad thing. That is, of course, a good thing, but I think there are relatively well-known weaknesses in just focusing on net zero, and sometimes it's phrased as carbon neutral growth, which I think means carbon dioxide neutral growth, of course, which essentially, if you think about it, means, well, we'll just continue as we are, and we'll in some way offset and make it overall neutral. But all that's doing is allowing technology to enable unsustainable behavior. You're just kind of putting a sticky plaster over the problem. It's an analogy might be, okay, right now we've got 20 million cars on the road all using fossil fuel. Let's swap them out for 20 million electric vehicles. You're just moving the problem to somewhere else. It's the energy is still the same. A better way to think about sustainability is, okay, well, what are all of these journeys that which are necessitating the cars? Can we look at a different way to fulfill that need? And that's happened a little bit with the times that we find ourselves in. Actually, the journey of commuting, we're finding is less and less important, and actually we can work from home. So looking at actually sustainability is not just about enabling unsustainable behavior by offsetting in some other way. Also, it's not just climate change or being environmentally responsible. And one way of thinking about this is, if climate change wasn't happening, what factors would remain? This is all part of considering sustainability. So what about things like peak oil and securing material supply? Any business that wants to be resilient has to consider long-term access to the materials and components that they need, and an ability to actually dispose of expended products, and use of natural resources. Natural resources don't go on forever. So that's just, I guess that's just an interesting way to look at things. Is what does it also not mean? So let's bring it all together then and look at sustainability and space, and put the two things together, and have a think about that. So um, I think probably one of the first points I would make is that the shape of the industry itself dictates how we frame the question. So if I'm showing another graphic here from that Size and Health of the UK Industry report, which shows actually the majority of the income of the industry comes from space applications. So this is, use of data, use of satellites as a service. A big example of that might be tracking. AIS tracking of shipping is a big data service, and selling that data is a very lucrative business. And there are many other examples. The Internet of Things type technology as well, and you can see that's 46% of the overall industry, and then the second highest percentage is space applications other. So it's combining those two, it's actually the vast majority. So the interesting thing is actually the majority of the industry, the space industry in the UK, is actually on the ground. And I guess that's just an interesting way of looking at it, in that if we want to have a sustainable space industry, a big part of it, it's not the complete picture, but a big part of it is considering actually what we do on the ground. And often when people see the word space and sustainability, they think, okay, well, I've got a pretty clear idea about, okay, satellites and debris problems. But let's build a resilient industry by looking at the sustainability of actually what's happening on the ground. And that kind of brings into focus the things like the basics of energy supply and sustainable practices on the ground. Um, uh, if we then think about the manufacturing industry, the satellite manufacturing industry, when I think about it, I think it's actually not so unique. It actually shares similar challenges to other engineering disciplines like the automotive industry or other manufacturing industries. Things like scarcity of supply and supply chain resilience, and similar things, making our processes and our offices sustainable in terms of energy supply, and the way that we do business as well. Um, so I think in that respect, the challenge for new space, if I was to kind of reach an early conclusion, the challenge is that we need to start well as an industry. We're still a nascent industry, it's still early days, and we need to start well and set an example for other industries. And my experience is that it's a high tech industry, and it's got a lot of uh, very smart people in the industry, and I think we understand the issues, and we have a really great opportunity to actually set an example for other industries and build a really strong beginning. And a big part of space and sustainability is the role that space actually plays in helping us tackle the wider problems in the world. So I thought it would be meaningful to actually take a little bit of a segue um, and look at some of the roles that space plays in sustainability around the world. So here's just a little infographic, if you like. And the reason I put this up is because any any activity that we do, whether it's space or any other, transport or anything, its value is in how it brings a measurable and sustainable economic or societal benefit. If something wasn't of any benefit to society or economically sustainable, then generally it doesn't last long. Um, but the usefulness of we're talking about space today and space technology, is that it is actually very directly useful to the world, and without presenting a hazard to anyone. um, and we need to do that in a way that doesn't compromise the capability of future generations to meet their needs. So here's just a few examples of things that satellites and the space industry can play a role in making for a more sustainable future for all of us. Um, Things like vessel safety, forestry management, even tracking of illegal fishery activity. Um, I was part of a project not so long ago which was tracking pirates in the ocean. Very interesting project. Very well known, of course, is environmental monitoring, and monitoring of climate change. So I've done a little bit of I've pulled this image here of the role that satellites can play in looking at climate change processes. Um, and one of the really key things that satellites can do, which ground instruments struggle with, is actually being a single instrument which is monitoring globally. So if you have many instruments in many locations across the world, then you have the issue of calibration. Many different um, instruments calibrated in a different way to a different standard brings its own unique challenges. Whereas a satellite is a single instrument able to make a global measurement. And that is one kind of unique thing that satellites are able to do. I read something very interesting recently about monitoring the movement of the ground for detection of seismic disasters, and predicting them, and better understanding of the mechanisms is something that is incredibly challenged to visualize all the data if you're trying to make ground measurements, but being able to make measurements from space has actually yielded really significant benefits. And actually, things more recently, there's been a big role in the COVID pandemic, looking at correlation of infection rates with things like surface air temperature, an increase in air temperature or decrease in air temperature having an effect on the infection rate. So, sustainability, we have to justify every activity we do to make sure that it is actually providing a net benefit to society for its cost that it has on society. And I see a real great benefit for a lot of these processes that you see. So, addressing then some challenges that we find in the industry today, beyond the ones I've already mentioned. Of course, we have to talk about debris and sustainability of space environment. And this it's a challenge that is talked about a lot, and I think it's well recognised within the industry, and there are actually some emerging solutions which are creating already significant new opportunities and new possibilities for reducing the amount of debris on orbit. So the famous image you see here of many objects. The one thing I would say is that even with many objects, let's not underestimate how big space is. There's something like 23,000 debris objects and 1,200 working satellites operating in an orbital environment. And if you had all of those objects and put them on the surface of planet Earth, then there would be a big distance between them. There's not that. If you imagine, say, 23,000 people on the surface of planet Earth, it's going to be a while walking before you meet someone else. And amplify that out to the vastness of space. Sometimes these images can tell a little bit of a lie, in that it looks so busy, but space is pretty big. Um, but anyway, it's not to say that there aren't challenges. So let's have a look at some of the numbers, the updated numbers that came out in one of the recent sessions that the UN had. And you can see here, so this is total objects on the y-axis there, and then year on the x-axis. You can see rocket bodies is kind of the lowest population, mission-related debris slightly higher, spacecraft higher again, with obviously you can see quite a significant increase there. And then the rest of it is debris in the pink line there. And it's very interesting to see the biggest step changes was the Fengyun 1C, and that was a test to where one satellite was destroyed on orbit and created all of these debris fragments, and then obviously we have the collision there between two satellites back in the late noughties. And then just another way of stating it as well is looking at the actual mass in orbit for different orbits. So these are some of the popular orbits, LEO, MEO, GEO. So GEO is geostationary. That's where most of the telecommunications satellites for things like Sky TV, etc., they always sit above a certain point on the ground. Medium Earth orbit would be something like the GPS constellation, and then low Earth orbit is generally lower again, so maybe underneath 2,000 kilometers altitude. And this is where most of CubeSats and small satellites operate. So you can see, actually when you look at the mass in each of these orbits, it's not so different, all of the different masses. So then what these are the numbers, right? And this is the problem, but what are the solutions? So I think one of the main things that's coming out from the analysis right now, there's a number of different things to focus on here. One of them is just simple compliance to post-mission disposal requiremts. So this is moving your satellite to a graveyard orbit, or deorbiting your satellite out of orbit so that it re-enters into the atmosphere. So what we're seeing is that still many missions are making literally no attempt at post-mission disposal. And when you look at the requirements that some of the major international bodies are putting forward, things like the United Nations and other organizations, the requirements are generally not so arduous. To actually first of all, passivate your satellite, so deplete your batteries so that they don't become an explosive hazard. Get rid of any fuel that's on board, again to reduce the risk of any kind of an explosion or fragmentation event. So that's one thing is passivation, to not charge your battery anymore. But outside of that as well, just being able to, if you are in the geostationary altitude, move away at the end of your mission by 100 kilometers or so out of the main busy geostationary positions, and then in the kind of lower Earth orbits, to make sure that your satellite does re-enter within 25 years. So I think when I see the requirements, I don't see the requirements as being very, very arduous, and I do accept that there are many different satellites out there doing many different things. It's not straightforward, but I do think if this is something where we can all tackle it together, I don't see many barriers to this, to compliance. And if the analysis is showing is that if we do have something like 90% compliance to post-mission disposal requirements, that the problem diminishes significantly. So that's one thing. Another thing is actual situational awareness. So this is ability to react to what's happening and be able to detect debris objects. So it's well known that the International Space Station has to make a few maneuvers per year to avoid debris, and the only reason they can do that is because, one, they have the ability to maneuver, by thrusters or some other actuator, but two, they actually know that an object is coming towards them, and this is situational awareness, and it's important that we continue to build on our capabilities as an industry as regards situational awareness, and the most recent reports are coming out that we do still have some gaps in detecting particles. So in particular, particles which are about the 1 millimeter size at an altitude of about 1,000 kilometers, there seems to be a bit of a gap in our ability to detect these particles at all. So it's continuing to develop our capabilities in that respect. There is an issue as well. Some of the most popular orbits are around kind of 550 kilometers, around this kind of altitude. And if you have satellites which are at a higher altitude, maybe 600 kilometers, let's say, or higher, then these objects their orbits will decay as a result of many factors. So solar wind, atmospheric drag, cosmic particles, all of these things. So these objects will be slowly but surely decaying and would eventually find their way to burning up and re-entering the atmosphere and becoming dust and particles. But before they do that, they're going to have to pass through every other orbit. 600 kilometers becomes 590, 580, 570, and then it's going to pass through 550, which I've just said is one of the most busy orbits. So there is an issue of higher altitude objects decaying through lower altitude orbits, and that's something that we will again, it's the situational awareness and being able to dispose of your satellite in a way that's controlled and avoids these issues by either adjusting your orbit or adjusting your trajectory. So right now there has been a series of focus points put together, and these are the kind of things that you'd expect. So just to list them off: reduce debris during launch, improve the resilience of spacecraft structures, so not having parts breaking off, improve shielding and impact resistance, generally by design of satellites to reduce or limit. Never generate any. If you have to separate or create some kind of actuation, make sure it's not something that's explosive that then sends some particle or something off into its own orbital trajectory. Being able to maneuver is a really crucial one as well. That many satellites don't have any ability to maneuver, and therefore they don't have any ability to react. They're an object which is flying in a trajectory with no adjustment possible. So being able to improve our maneuverability has a big possibility for reducing the risk of fragmentation events. And then, as you say, that end of life disposal aspect. There are new things coming through as well to try and incentivize compliance. Things like cheaper insurance, and there's actually a space sustainability label potentially being developed to kind of enhance public opinion about a particular company. But generally, this is countries and companies deciding for themselves to make this a priority for their own reasons, be it commercial or public opinion or cheaper insurance or any other consideration that they consider to be important. And it mainly is down to the decisions of individuals and countries and companies. So. Okay, so just bringing us to a close then, and we're going to move to a time of question and answer in a minute. So if you do have any questions, you can put the forward in the chat window there. So just to conclude then, as I see it, the industry is responding very well, and there is a recognition of the importance that everyone wants to continue using space. Therefore, we see the sustainability of space as something that's really important. And because the satellite industry plays such a central role in monitoring climate change, and all of the things to do with sustainability, we almost see it firsthand, the importance of getting this right. We do have key recommendations coming through from the main organisations that you would think of: the United Nations, NASA, JAXA, and we need to continue to comply to these recommendations. We need to prioritise post-mission disposal, but we do need to also think about the sustainability of what happens on ground. As I said, that is a big. It's not the whole picture. You know, it all works together. But looking at computing, manufacturing, and the downstream industry of data processing, you know, let's make these also sustainable. Because the objective here is to make an industry which can continue. And you know, I've become part of this industry because I find it inspirational. There's something about space which is particularly awe-inspiring and captures public opinion, and we see that all the time nowadays in the headlines, the big launches, and I want to see that continue not just into the short-term future. I want to see it sustainable into the long-term future, because I want to enjoy that for many years to come, and I think we can do it. Okay, so that's the conclusion of the presentation. We're now going to move into a time of questions and answers. So yeah, let's have a look at that.